Hey, I'm Nicole. This is part 2 of my Understanding Compression series of videos, so if you haven't seen part 1 yet and aren't familiar with the basics of compression, be sure to go back and watch from the start. Last time we went over the basics of compression and how it works. This time I'll be going over all the different types of compression and also expansion with examples of how they might be used, and I'll also try to throw in a few tips and tricks along the way. Wait, expansion? What the hell is that? Well, the first step in understanding both compression and expansion is knowing why they're named the way they are. Compression is called compression because it reduces or compresses the amount of variance an audio signal has in its volume, whereas expansion aims to increase the differences in volume an audio signal has to make the differences even larger, therefore increasing the dynamic range. That's not to say that whenever you use a compressor, you're reducing the dynamics of a signal, and whenever you use an expander, you're increasing them, as with the aid of attack and release controls, the opposite can be true, but this is just the foundational idea behind each approach. Just like in the first video, if this first little part of the explanation has got you a little confused, don't worry, I'm going to try explain it as best as I can. So if you remember from part 1, we talked about normal compression and how it works. And 99% of the time when someone says the word compression in a sound engineering context, they're referring to what I was talking about in part 1. However, there are a few other types of compression as well as its evil twin, expansion, which also has its own various forms. First, let's talk about the other forms of compression. I've drawn out a few simple diagrams emulating Ableton's stock compressor's transfer curve view, which you hopefully remember from part 1. Since Ableton's compressor isn't actually capable of producing all of these compression types, you won't actually see these displayed within live stock devices, but the transfer curve view is a great way to visualize and compare all the different compression and expansion types, so let's use it anyway. Remember, compression is basically just a super fancy and detailed way of automating the volume of a signal. All of the different styles of compression and expansion I'm about to talk to you about are just doing it in different ways. First off, we have this perfectly straight line. As you should know by now, this just equates to no compression at all. Then we have normal compression. The actual proper term for this is downwards compression, because when the signal exceeds the threshold, we're lowering the volume. Since it's by far the most commonly used, this is what people are referring to when you hear the word compression most of the time. If we increase the ratio to its maximum value, this is now called limiting, because everything above the threshold is being limited to a single static volume level. This is also extremely common. Pretty much every popular song released in the last 30 years has been limited in some way during the mastering stage to get it to consumer levels of loudness, and this can also introduce some pleasant and sometimes unpleasant distortion depending on how far you push it. Lastly, we have upwards compression. As you can see from the diagram, in this form of compression, everything above the threshold is being left alone, and everything below it is being raised in volume, hence the name upwards. This can be used to bring forward quiet details in a signal you feel could be louder. Upwards compression is most commonly used in a multi-band or parallel compression scenario, but we'll cover that in part 3 of this series. That's all the forms of compression covered. Now we'll move on to expansion. First off, we have upwards expansion. This is when everything above the threshold gets raised in volume. This can be useful for increasing the dynamic range of a signal. For example, if you have a drum loop that is just a little too flat and lifeless, adding a little upwards expansion and bringing each drum hit up in volume slightly while leaving the quieter hi-hat or ghost notes alone can inject a little more life into the loop. This is probably the least common out of everything we've covered so far, but can also have its uses in a multi-band compression scenario. The next one, however, is actually quite common, and it's downward expansion. This is where we decrease the volume below the threshold. This is extremely common when live recording drums, because by using downward expansion on a mic'd up snare, for example, you can reduce the volume of all of the other drum pieces that are being played, which you don't want audible in the snare channel. Same goes for the kick. You can reduce the amount of snare bleeding through the kick mic with downward expansion. Actually, in this scenario, you're technically more likely to use a noise gate, which is just a downwards expander with the ratio set to the maximum value, which completely removes noise that isn't loud enough to make it past the threshold level. A lot of the time, people will just refer to downwards expansion as a noise gate regardless of the ratio. There's also a lot of other shapes we can make with this diagram. Some more valid for music production than others, but I've covered the main ones you'll come across. For instance, there's this one. Pause the video here and see if you can figure out what we're doing with the audio signal if you want. This is just an inverted noise gate. So instead of cutting everything below a certain threshold or volume level, we're cutting everything that exceeds the threshold. There's also this one. Probably don't go out of your way to replicate this one unless you want severe tinnitus. Okay, so let's go over a few practical applications. I'll be quickly running through them for the sake of the length of this video, but may go over them in more detail in the future. You should understand how they work and why you'd want to use them after I'm finished though. We've already covered downward compression in the last video, so why don't we start with upwards compression here? The main way I would use upwards compression by itself is to bring up the small details of a signal that might lie in between heavy transients. If we take this drum loop for example, it's got a lot of really nice, intricate ghost notes happening. Maybe we can bring those out a bit more and make it sound a little bit more interesting. Just turning the track up won't work because it'll bring the kick and snare up by the same amount. So I'll put some upwards compression on it to bring those quiet, fine details up a little without affecting the kick or the snare as much. Don't worry about what's on screen if you're unfamiliar with Pro MB. Just listen to what's happening with the signal and have our diagram in mind. What we're doing here is actually really similar in sound to what most people would call parallel compression. Although when most people parallel compress, they do it with a downwards compressor in a special way that ends up giving this effect. You can really start to hear the parallel compression type sound when we push it to extremes. Let's also quickly go over limiting. Limiting is very useful for getting things to sound loud and heavy. Listen to the snare. Its peak loudness is basically at 0 dB, so any louder and it will start clipping and distorting. But it still sounds kind of weak, so why don't we try limiting it and see what happens. As we push the signal further and further into the threshold, the waveforms are basically getting chopped off and limited at max volume level. This causes distortion. At lower amounts of limiting, this distortion is inaudible. Push it harder and it starts to become noticeable. Since more and more of the signal is staying at that peak volume level, the more we push the signal into the limiter, it sounds perceivably louder to our ears. If we push it too far, the signal ceases to sound any louder and starts losing its impact instead. More perceivable loudness at technically the same measured volume level. This is the true strength of limiting. The distortion from limiting can either be desirable or undesirable depending on your sounds and genre, so the amount you'll want to use it is totally dependent on the situation. You'll generally want to find that sweet spot where the distortion isn't too over the top, while adding a little bit of that heaviness you get from pushing the signal into the brick wall threshold. without making it sound like a flat and lifeless sausage. Next is downward expansion or noise gating. I already explained the most common usage for this earlier, so let's try something a little bit different. I've got this drum loop. I really want to put some reverb on the snare, but I don't have the individual drum piece stems. So why don't we send the signal to a return track? We'll solo the return track so we can only hear what's going through it. And we'll put a gate on that return track and try make it so we can only hear the snare. We want the full snare sound, but some of that kick is still coming through. So why don't we put a EQ before the gate and try filter out the main part of that kick with a high pass filter. Not bad. Now we can add some reverb. Make sure the mix is at 100% so that we're not hearing the original snare signal twice, and then adjust the level of the reverb by changing the level of the return track. Awesome, we've successfully put reverb on the snare only, even though we only had the full drum recording to work with. And what if we invert the gate by clicking the flip button? We've now added a really nice airy vibe to the quieter parts of the loop without affecting the kick and snare as much. And now that we have Ableton's stock gate open, why don't I explain it properly so you guys know exactly what you're doing. So the attack and release do exactly what you'd expect them to do. It's just that this time on the gate they determine how fast the expansion is happening once the signal falls below the threshold. Hold sets the minimum time that the signal can be reduced in volume. So if you have a signal that only falls below the threshold for 50 milliseconds, but your hold is set to 1 second, the signal will just stay cut for the full second, regardless of when it actually goes above the threshold again. The other main difference between a normal compressor and a gate is that they usually have a threshold and also a return knob. You can just think of the return knob as a second threshold value. The difference being that the return determines the level at which the signal stops being cut on its way back up after being cut or reduced in level. And floor is simply a lower limit to the amount of cutting you can impart on the signal. For example, if the floor is set to minus 35 dB, the gate will still let through minus 35 dB worth of volume, even if the signal is otherwise fully gated out. And look ahead adds the displayed amount of latency to your project to give the CPU time to process incoming signals, so that any quiet signals that should be gated aren't missed for a split second as the gate starts working. Lastly, we have upwards expansion. This isn't used as often as the other things we've already discussed, but it can come in handy if you want to add just a little bit more dynamic range to a signal. Take this percussion loop for example. It's nice, but might sound even better with a little more groove in the difference in volume of each hit, especially if I'm going to use it in a bridge or quieter section of my track. Let's drag Ableton's stock compressor onto the channel and change it to expand mode. We'll bring down the threshold a little bit, and I think a fast attack and release for this will suit quite well, and make the release just short enough so that it's catching each individual hit. We'll bring the ratio up a little bit. And now we can adjust the threshold a bit more until it sounds exactly the way we want it. Note that when expanding instead of compressing, we no longer need to use makeup gain. In fact, we actually need to take gain away or lower it in volume the more we expand the signal if we want the output to be the same max volume as the original input signal. So why is downward compression so much more popular compared to these other things? Well, with the aid of attack, release, and makeup gain, there are just so many different possibilities in terms of how you can process a signal with downwards compression. It's almost become a Swiss Army knife for many producers over the decades, but if you find any of these other forms of compression or expansion interesting or useful in your own work, there's really no reason not to use them. That's all the basic versions of compression and expansion you'll come across. Downwards compression and downwards expansion are definitely the main ones to get familiar with, as you can get a lot of desirable results you'd want with some attack and release tweaking, especially when you add makeup gain to the equation, not to mention side chaining, which we'll cover in a future video in this series. In part 3 though, I'll be going over multi-band compression using both Ableton's stock multi-band dynamics device and also parallel compression and some other third-party plugins so you can visualize it a bit easier. Thanks for watching. If you have any questions or suggestions, please get a hold of me by joining my Discord server. I'll leave an invite link down in the description. I also have a Patreon where you can access the project files or stems of any of my tracks, plus monthly lessons or support with anything you might need regarding music production, including feedback and guidance on your own tracks, as well as other benefits. Until next time, cheers.